possible. Then coming to the last type of search techniques. Okay, this will be the last type of search technique which we will see, and later on from the next unit onwards we will shift to how to use these search techniques and come for inference, how we are going to solve the problems. Here we are only defining in this unit, we have seen all type of searches, because to solve any problem we need to do a search. So that is what we are seeing. So one more type of search algorithm is called as hill climbing algorithm. Okay, so we will see what this hill climbing algorithm is. So it is a local search algorithm which continuously moves in the direction of increasing elevation value to find the peak of the mountain or best solution to the problem. It terminates when it reaches a peak value where no neighbor has a higher value. See, just assume that our problem given is to climb a mountain. Okay, so when you are climbing the mountain, our ultimate goal will be to reach the highest value or the highest range in the mountain. So that is what we are trying to say. So whenever you are climbing a mountain, you are going to come across a lot of issues. Okay, so I will just show you one more diagram, then we can come back to this slide. See, supposing you can assume here, this is the mountain you are climbing. I will show here. So you are climbing a mountain means different points will be reached here. So the global maximum is the highest peak which you can arrive at. But then when you are climbing, you may come to a place where it is called as a shoulder or a plateau. For a long time you will be simply walking across a flat region. You don't know where the peak is. So that type of situations may arrive. And then you could reach the mountain, but you may not know that you have reached the tallest peak. So you may come down, or you may come at a local maxima. You may feel that this is also a peak. So you may feel that this is the topmost region. But then you may at times by mistake come to a lower point which is called as a valley. Or there can be a flat local maximum and so on. So as you are climbing the mountain, you will come across various types of states where you can be misled or you can be caught. But the ultimate aim is to find the global maximum. Okay, so the same thing is compared to our problem solving also. Any problem given, I could be going and I may not find the right solution. For some time I may be simply running in the program without finding the solution and so on. So that is why we are comparing it with this hill climbing technique where we will use heuristic and try to move on. Okay, so here also we have defined those things. We told you those points, no? So if I know that I am in a shoulder, then I know that after some time I will be reaching some maximum. And whenever I reach a maximum, immediately there will be a valley. You will be falling down. So like that you can define and you can slowly try to find the solution. So that you can again use the generate and test method. That is to say, you find out all the possible solutions and then you try to come out of it. Or you can go for a greedy approach. You can search through optimized cost, whichever is taking lesser time, lesser cost. And you can also use the method by which you are not going to backtrack. So if you don't backtrack, you don't need to remember the previous states. That also is an advantage. So we can use any of these methods for hill climbing. And there are 3 types of hill climbing algorithms. We will see them a little later. So as I told you, we are drawing the state space landscape as a XY axis, where the object function is in the Y axis and the state space in the X axis. And I told you these are all the various regions. So we can have a shoulder region or a global maximum, local maximum, a flat local maximum, and also the wherever you are traveling, that will be your current state. Okay, so I have explained what each is. Local maximum means local maximum is the state where it is greater than its neighbor, but it is not the highest point. Whereas global maximum is the highest value of the objective function. and current state is where you are currently situated, and flat local maximum will be the place where everywhere the same value is. Okay, flat local maximum. And shoulder is the plateau region, which means after some time you are going to see the uphill range. So soon after the plateau you will be climbing up. So these are all the various states I can be in a problem solving situation. Okay. So with this in mind, we will see the types of hill climbing. Yes, welcome students. This topic we will see the types of hill climbing algorithm. So the very first one is simple hill climbing. We can have a steepest ascent hill climbing. We can also have stochastic hill climbing. So simple climbing is the simplest way to implement. It will only evaluate the neighbor node state at a time, and it will select the first one which optimizes the current state cost, and it will set it as the current state. So it will keep on checking whichever the state is coming, it will simply keep climbing. So less time consuming, less optimal solution, because we are not guaranteed of getting the right solution. We are simply taking, if you take the example of the mountain climbing, you are going the easiest method. You are not going to jump to a higher cliff, you are not going to take a difficult path. Whichever is coming easier to climb, you keep climbing. So you may not arrive at the optimal solution. Okay, so we'll evaluate the initial state, then return if it is successful. Otherwise we will keep on looping. Then we will find the next state. If it is better than the previous one, you will assign to the new state and keep moving. Whereas steepest ascent hill climbing, you are not going to take the easiest method. So what you will do is you will examine all the neighboring nodes and the current state and select one neighbor which is closest to the goal node. Okay, so we are going to do some little more difficult task. We are not going to take the easier step. We are going to compare all the situations. Whichever is nearer to the goal state, then we will try to go through it. So same way we will generate, then we will loop, and each time you find a better solution, you will assign that to the current state, and then you will keep on moving. So that will be the condition for a steepest ascent hill climbing. And each time you will check whether you reach the goal state. Whenever it is the goal state, you can return and quit. But if it is not the goal state, but it is better than the previous state, you will assign it as a better state and keep moving. Then stochastic hill climbing does not examine all its neighbor before moving. Rather, this search algorithm searches one neighbor node at a time and decides whether to choose it as the current state or examine another state. Okay, so it is neither the first method or the second method. In the first method, we were simply going by the next state. Whereas in the second method, we found all the possible solutions, and then whichever is best we kept moving. But here we are not going to examine all the neighboring solutions, but we will randomly choose. Stochastic means it is having a random process. So we will randomly choose one state. If it is okay, we will jump to that state. If it is not okay, we will choose another random state, like that. We are not going to, supposing there are 10 states, we are not actually examining all the 10 states and wasting time. We are doing some heuristic approach here, by which we are going to take only random states. Okay, so all these, whenever we are climbing, I told that there are some situations occurring. So these are all actually problems, because our ultimate aim is to go to the global maximum. So if I find a local maximum, it is a peak state in the landscape which is better than its neighbors, but it is not the correct situation. Okay, so if this is my goal, supposing the topmost region in this diagram is the goal, I might have reached here thinking that this is the goal. So I should not stop here, but I should backtrack and keep continuing the search. Okay, so whenever I arrive at a local maximum, it is a problem. So I have to overcome it, and I have to create a new list of promising path and keep tracking back. Supposing I might have missed this peak and come here, if I am traveling from here, so that I might have reached here and I might have thought that there is a peak higher than this. So if that is the case, I would have come here to the local maximum. Then I have to backtrack and go back to my original value. So that is how I will be carrying this search. So these are problems which we come across, which we will overcome. So similarly, the plateau region also, I told you, we have to keep on walking till we come to the peak. We may think that it is not going to give a solution and we may stop searching. So plateau is a flat area of the search space in which all neighboring states seem the same. Okay, so we may be lost in the plateau region. So the solution will be that for the plateau is to take big steps. Okay, rather than taking small steps and assuming that there is no solution, we have to keep moving, taking larger steps so that you cover the plateau faster. Because at the end of the plateau, there might be definitely some solution leading to our goal state. Okay, so we have to, the solution here whenever we encounter a plateau will be to keep moving for a solution by taking longer steps. Similarly, I may come across ridges, that is up and down it may be going. So we will have a local maximum, then we will fall down to a valley and so on. But then it is a bidirectional search, so you have to somehow keep moving. We cannot stop because we have landed in a valley. We have to keep climbing till we go to the goal state. So whenever we come across a ridge, then we have to use bidirectional search by moving in different directions so that we improve and find the solution. Then the last type of approaches, see all these AI techniques actually we are comparing with the real world scenarios, and then we are trying to arrive at some algorithm. See, we saw very well in the previous one, we took the example of how a human being is going to climb the mountain, what are all the challenges he is going to face, and on that we did some research, we found all those checkpoints, and we also evaluated how a human being is overcoming it, and the same way we are comparing it or giving it an analogy with the AI problem. So similarly here also there is something called simulated annealing. This happens mainly with our mechanical engineering or manufacturing processes. So whenever we want to make an iron rod into some shape, what we will do is we will actually heat it. Any metal or glass will be heated at a high temperature, and then while cooling it gradually you can bend it or convert it to any shape you want. So that is the understanding here, and it should not be heated beyond a temperature, or if it is very cool also it will not work out. Okay, so this simulated annealing is a algorithm which yields both efficiency and completeness. So just like how the metal or glass at a high temperature and then cooling gradually, it allows the metal to reach a low calorie crystalline state, meaning to say in a state wherein it can be bent and created into very constructive objects. So that way we are going to do, we are going to use this method for our search technique, because we found that in the hill climbing problem there are so many issues encountered. We may not be guaranteed to get a complete solution. So we are going for this method. So normally what happens in this simulated annealing, generally it depends on the temperature and based on the temperature accordingly you can go and do various things. So if the temperature is 100, 80 like that, depending on that different colors have been shown. So that temperature, that property like that you can do. So the same way we can compare it to our AI algorithm also. See, as the temperature decreases, the search or the optimal solution also will be, the probability of approaching it will be found. So we are comparing that analogy with this. and we are trying to use this technique, just like how the simulated annealing will be happening. The same annealing process you are simulating it for a search technique. And this comes under this Markov chain Monte Carlo algorithms. These are all very high topics, so it is not possible for us to explore to that level. So you can simply understand that we are trying to use the real world scenarios also into our software techniques, and based on those characteristics also we are trying to arrive at solutions. Okay, so with this we complete all the search techniques, and next topic onwards we will see how we can apply these search techniques for the various applications of artificial intelligence. Thank you, students.